Hi all. Today in this video we are going to learn the response of critically damped second order system for unit step input. And we know that this is the transfer function of second order system. Okay, that is C of s by R of s equal to omega n square by s square plus 2 zeta omega ns plus omega n square. And we know that for a critically damped system the value of zeta will be is equal to 1. And if you are substituting the value of zeta in the transfer function, it becomes omega n square by s square plus 2 omega ns plus omega n square. And that is this equation we can write as s plus omega n square. Okay, it is the expansion of s plus omega n square all square, s plus omega n all square. So C of s by R of s equal to omega n square by s plus omega n all square. And we know that we are going to give an unit step input, that is R of t is 1. So the Laplace transform of this one, that is R of s, will become 1 by s. And our response, that is C of s, will be equal to R of s into omega n square by s plus omega n all square. Okay, just multiplying with this R of s, and we are going to substitute instead of this R of s as 1 by s. So C of s becomes omega n square by s into s plus omega n all square. So we have to find the Laplace inverse of this function. Okay, this entire function. So by partial fraction expansion, so we can simply split the entire term into 3. Okay, so that is, the first term will be a by s, and the second term will be b by s plus omega n square plus c by s plus omega n. Okay, so by partial fraction theories, so this is the form of expansion. Okay, this is some form of splitting the terms. Okay, if you are having a term like this, s plus omega n all square. Okay, if you are having s plus omega n all cube, it will be b by s plus omega n all cube plus c by s plus omega n square plus d by s plus omega n, like that. Okay, so here we have to find the value of a, b and c. Okay, you can use any method for finding the value of constants a, b and c. Either you can just cross multiply the term. Okay, just cross multiply the entire terms and equating the coefficients of s square and equating the coefficient of s and equating the constants, you can find the value of a, b and c. Or you can use this method. Okay, so according to this method, for finding the value of a, we are going to multiply the denominator, that is s, with the entire c of s. Okay, so s and s will get cancelled. Okay, and the remaining term is omega n square by s plus omega n square, and we are getting the value of s to 0 here because the value of solution of s is 0 here. Okay, so s equal to 0, and we will get a as 1. And for finding the value of b, we are going to multiply the denominator, that is s plus omega n square, with the entire c of s. So this s plus omega n square get cancelled, and we are getting omega n square by s. Okay, the remaining term is omega n square by s, and we are just substituting the value of s. What is the solution of s here? Okay, the value of s will be minus omega n. Okay, this s plus omega n square is equal to 0. Okay, just equating this s plus omega n square is equal to 0, we will get s is ss minus omega n. Okay, and if you are substituting the value of minus omega n here, the one omega n and omega n get cancelled, and b is equal to minus omega n. Okay, and for getting the value of c, okay, we have to just differentiate the function. Okay, actually d by ds of s plus omega n square into cf, that is d by ds of this function. Okay, so this function we will get it as omega n square by s. Okay, that is omega n square by s. So we have to find the derivative of this omega n square by s, that is d by ds of omega n square by s. And we know that the omega n square is constant, and the derivative of 1 by s, we know that the derivative of 1 by s is minus 1 by s square. Okay, d by ds of 1 by s is minus 1 by s square, so it becomes minus omega n square by s square, and we have to substitute the same value of s, that is s is equal to minus omega n. Okay, same value of s, so s is equal to minus omega n, while substituting the value of s is equal to minus omega n square instead of s here. So s square will become omega n square, that is minus omega n into minus omega n become omega n square, and we will get cs minus 1. Okay, and we are going to substitute the value of a, b and c in the given equation. Okay, so it becomes 1 by s minus omega n by s plus omega n square minus 1 by s plus omega n, and we have to take the Laplace inverse of c of s. for obtaining C of t, that is in time domain, response in time domain. So we know that Laplace inverse of 1 by s is 1, and the Laplace inverse of omega n by s plus omega n square. Okay, here omega n is constant, and we know that the Laplace inverse of 1 by s plus omega n square. So we know that it is in the form of this equation. Okay, that is Laplace transform of t into e raised to minus at. Okay, you may be studied in the previous classes. Okay, previous mathematics lectures. That is Laplace transform of t into e raised to minus at is 1 by s plus a square. Okay, 1 by s plus a square. So Laplace transform e raised to minus a t is 1 by s plus a, and Laplace transform of t is actually it is 1 by s square. Okay, so by combining that we will get 1 by s plus a square. Okay, so here instead of this a we are having omega n. Okay, we are having omega n, so it becomes what, that is t into e raised to minus a t. So omega n is constant here, so t into, instead of this a we are having omega n, so t into e raised to minus omega n t. Okay, and we know that next term is 1 by s plus omega n, it is e raised to minus a t. So instead of this a we are having omega n, so e raised to minus omega n t. So this is our response, and we are taking outside this e raised to minus omega n t common. So it becomes C of t is equal to 1 minus e raised to minus omega n t into 1 plus omega n t. So this is the response of a second order system for a that is critically damped second order system for unit step input. Okay, and if you are giving a step input of amplitude a, for finding the response we have to multiply the amplitude a with the entire response, and this is the response figure. Okay, this is the input r of t we are giving unit step input, and in the response we observe that the response have no oscillations. Okay, no oscillation, the second order system have no oscillations, and it is approaching to the final value 1 as time t increases. Okay, so I hope all of you understand the derivation well. So thank you.